This video is on the identity matrix. An identity matrix is a diagonal matrix with ones down the diagonal. Because it's a diagonal matrix, it's a square matrix. So just to simply demonstrate, we can have a 3 by 3 identity matrix with the ones down the diagonal and zeros everywhere else. Now this is pretty much like expressing the number 1 in algebra. So if you had 3 times 1, obviously that equals 3. The number multiplied by 1, in this case 3, remains unchanged. So the identity matrix works in a very, very similar way, if not the same. So let's do a simple example. Let's say we have matrix B is equal to 0, 6, 1 going across, 0, 5, 2. Sorry, I meant 7, 6, 1, 0, 5, 2, 3, 9, 4. Okay? So let's multiply B times the identity matrix. So B times I, 7, 6, 1, 0, 5, 2, 3, 9, 4 times 1, 0, 0, 0, 1, 0, 0, 0, 1. And that's going to give us the same thing, 7, 6, 1, 0, 5, 2, 3, 9, 4. So it's basically just like algebra, basic algebra here. When you multiply it 3 times 1, you get 3. When you multiply a matrix times its identity, you get that matrix again. So I guess you can say this is the Born identity. Now order is very important. Order must be selected to be conformable with the matrix, that is to be multiplied by it. So if you have a 5 by 3 matrix Y and you wish to multiply by an identity matrix, the order depends on whether you pre-multiply or post-multiply the identity matrix by it. So let's start with an example. To post-multiply Y by I must be a 3 by 3 matrix because we are going to make Y a 5 by 3. So I must be a 3 by 3 to get another 5 by 3 matrix. So let's say Y has the values going across 5, 0, 9, 8, 7, 6, 6, 7, 8, 4, 5, 10, and 2, 1, 7. We're going to multiply that by an identity matrix. And here's what we get. So I'll kind of show you by hand just the first one. What we do here is we take this 5, remember in matrix multiplication, take the first number in the first row times the first number in the first column. So 5 times 1, we're going to add that here. 3, second number times the second number in the first column times 0, plus 9 times 0. And we add that together, we actually get 5. Okay? And if we keep doing that, we will actually get the same values as Y. So 8, 7, 6, 6, 7, 8, 4, 5, 10, 2, 1, 7. I spared you the boredom from doing this process through each one, but just in summation, when you multiply once again a matrix by the identity, you will get that matrix again. So when you pre-multiply Y by I, I must be an order of 5, so a 5 by 5 matrix, in order to get a 5 by 3 matrix. So it's going to look like this. Ones on the diagonals there. We're going to multiply this by y. And what do we get? 1 times 5 plus 0 times 8 plus 0 times 6 plus 0 times 4 plus 0 times 2. So we did this first row times this column, added it together, and we get 5 again. And then 0 and 9 here. And like I said before, you'll just get y again. And I want to reiterate once again, it depends on whether you're post-multiplying or pre-multiplying on the size of I. Here we had a 5 by 3, and we know we're going to get a we know we're going to get a 5 by 3 again because it's just multiplying by the identity. So thus, this identity has to be a 3 by 5. Same thing goes here. Obviously, you can't multiply by a, sorry, I meant 3 by 3. You can't multiply by another 3 by 3 over here because that doesn't match up. You have to multiply by a 5 by 5 identity matrix. And we call this an order 3 and an order 5. Now let's go over to Excel. I know this is, if you've done matrix multiplication, which you should have done, this is kind of review, but I'm just going to do this quickly here. I've already put my y in, and here's the order 3 identity and the order 5 identity. So when we're post multiplying, okay, we're going to do y post multiplied by the identity of order 3, and we get the same thing. And then when we pre-multiply, make sure we do the identity of order 5 first, and then y. And let me actually extend that here. And there you go. That's a basic way of doing an identity matrix.